So in this chapter, we will deal with triangles, right? Three-sided. Then we're going to deal with quadrilaterals. They have four sides, three sides. Right? Triangles, three sides. Quadrilaterals, four sides. You can have specific names for certain shapes. Those you either have to have on your study sheet or you got to memorize them. And last but not least, polynomial. Sorry, not polynomials, polygons. Sorry. Different course, different course. Polygons. And that is just many sides. Okay? So they're specifically for three, we have a lot of properties and we focus on triangles, then four-sided, and then anything that has like more than four is kind of just referred to as polygons. Really, polygons encompasses everything, but triangles and quadrilaterals have like their own special section, okay? So, I'm going to skip a few of these prior skills. Let's go to page 4, and the reason why I'm skipping them is that I'm going to find a way to bring them in as we go along, okay guys? It's crunch time. Sometimes I do this unit at the beginning, so that's why then I give a bit more time. But the first thing is a review is Pythagorean theorem is really your hypotenuse squared is equal to leg squared plus leg squared, okay? That is really what the Pythagorean theorem states. I know you called it ABC, right? A lot of your teachers maybe called the long side C and then it's A squared plus B squared. I don't like using ABC because sometimes the triangles have different labels and then you mix it all up and it's all wrong after. So just think of it as the hypotenuse, which is across the 90, and the other two are called legs, right? That's actually what we're talking about here. It only works with right triangles, and you need two out of the three sides for this to work. Very rare that you will need this, but I am just preparing you just in case. If the hypotenuse is unknown, if this is unknown, okay, then I use this one. Leg squared. Sorry. Undo. Hold on, guys. What a good start to the semester, to the year. And then I use this one. Hypotenuse squared is equal to leg squared plus leg squared. That's really what the theorem states. Therefore, to just figure out what the hypotenuse is, you just have to take the square root of both sides. And that leaves you with the hypotenuse. And on the other side, it's just leg squared plus leg squared. And so on my study sheet, I would just have this version. Like this, if the hypotenuse is unknown, I will use that one. Emphasis on you adding the two legs, the squares of the legs, and then you square root it. If one of the legs is unknown, then it turns out that it would be leg squared is equal to hypotenuse squared minus one of the leg squared. You would have to subtract. And so to just figure out what the measure is of the one leg, you would just have to square root this. And this is the one I would have on my study sheet. So it's not ABC, but I think it's better. So let's put this into practice, right? You've got a triangle that is a right triangle, and you've got two out of the three sides. Which side is missing, guys? The hypotenuse is missing. So I got to use this version of it. So I will go hypotenuse is equal to This is a leg, and this is another leg of the triangle. So it's 7.6 squared plus 9.4 squared, and then we'll take the square root of that. If you have a calculator, please don't do this all in one shot. You just go 7.6 x2 squared plus 9.4 squared. Figure out what that is. Okay, 146.12 in my case. Then take the square root of that, and you've got the answer, 12.09. What are we in? Centimeters. And by the way, the hypotenuse is the longest side, so make sure that when you get your answer, that it indeed is the longest side. And in our case, it is. Okay. Next, label your first label, right? Across the 90, just start driving out and you figure out that this is the hypotenuse, which means that this is a leg and this is a leg. So you're missing one of the legs. One of the legs is unknown. Okay? So you would go leg, or you can call it x, whatever works for you, is the square root of the hypotenuse squared minus the other leg squared. I use my calculator here, right, 17.8 squared minus 12.6 squared, that's 158.08. Take the root of that, that's 12.57 inches. And make sure that the leg is not, it can't be longer than 17.8. So if you were to add these two, you would get a length that's longer than 17.8. You can't have that, okay? So that is your answer there. So I'm not going to give you more examples. It is just in case that shows up, you at least have seen it again, okay? If you want to try it, you can try on page 5. If you look at page 5 there's 3 questions. And all of them have the answer at the bottom of this page. If you look at the bottom, it's just upside down. I have the solutions right there. If you want to practice that, you can do that. Okay. In fact, if this is something you're like, I need a bit of a review on it, this is the page you would do it on. Okay. This is where it actually starts. Our unit starts here technically, working with triangles, okay? A triangle obviously has 3 sides. It's a closed figure, and this is important. This is the one that must be the case. If the province ever asks you what's wrong with this triangle, and they give you the angles, first thing I would do is add them up. Does it add up to 180? If it doesn't, it's not a triangle. It is not. You just can't make a triangle that has a sum of less than 180, okay? Classifying triangles. When the question, right, so I will highlight the classifying because now it's declassified, but we're talking about classifying. Classifying triangles, it means, what I call it is come up with a first and a last name. Okay? Every triangle technically has a first and a last name in this course. Okay? And so here are the differences. I will use 2 different colors. We can give it the first name, for example, if we look at the angle measures, like if we actually look at the angle measures. This would be the first name. And then you can also, every triangle can also has to have a last name, and that is when we look at the side lengths of the triangles. So the actual measure of the length, okay? However, this is somewhat of a lie. We don't always need the numbers when it comes to side lengths. We can also look at the markings. Okay, markings are also giveaways. Okay. So for example, when it comes to angles, you have acute, right, or obtuse. Only one of these three applies. Acute triangle, all three angles measure less than 90. Okay? All of them are less than 90. If it's a right triangle, there's one that is exactly 90 right there. Okay? If it has a 90, boom, it's a right triangle. There's no other option. Obtuse is if one angle is greater than 90. And in this case, it's pretty obvious that it would be right there. So then it's considered an obtuse. So that's the first part. The second part, we looked at the side lengths. Equilateral. I'm sure you've all heard of equilateral triangles, but here it is again. Equilaterals, three sides are equal in length, okay? But here's the kicker. Three sides are equal length, but also three angles are equal in measure as well. Okay? So all three sides are the same. That's why the markings are there. And all three angles are the same as well. Okay? Isosceles. Isosceles, you have two sides that are equal, and you've got two angles that are equal as well. Okay? And scalene is the one where all sides are different and no angles are of equal measure. Okay? So all sides are different and no angles are of equal measure. So to recap, all sides are, watch this. Normally we would just say equal, but in geometry we use congruency. Like things are congruent. It's still saying equal, but this is the symbol for congruency. Congruency is two things that are the same. Okay? All angles are also congruent. That's what makes a triangle an equilateral triangle. Isosceles, you've got two sides that are congruent and two angles that are congruent. This is the symbol for angles, by the way, in case you're wondering what is that. Right there, angles. Should have done the same thing here, right? And what about the last one, scalene? No sides are congruent and no angles are congruent. That's a scalene triangle, so you can kind of break this down like that. Quick question for you. Why can't a triangle have more than one obtuse angle? Explain. Why can't a triangle, I'm telling you that it's not possible, why can't a triangle have more than one obtuse angle? And this is why. Let's say one of the angles is 91 degrees. And let's say another angle is also 91 degrees. What does that add up to already? That's 182, right? Two angles already add up to 182, but that can't be because now this triangle has more than, there's two problems here. Your sum is more than 180 and you only have two angles, right? So can't be. Since sum is greater than 180 degrees and only has two angles. I mean, the same case would be if all three were 91. It still would be a problem. It'd be like 273. That can't be either, right? So you just can't have a triangle that has more than one obtuse angle. Let's keep going. Page 7. Now we're going to start classifying triangles. And sometimes you're going to have to go back to trigonometry, sine law, cosine law, to help you out. I don't think today that'll be the case. Steps to classify, this just to help you. Look for side lengths or angles given. It could be markings or actual values, right? So just look for that, observe. Number 2, are you able to determine all three angles using the sum of triangles equal to 180? If the answer is yes, okay, you have everything you need. You can classify, you can name it, right? If you have all three angles, you can actually do that, no problem. If the answer is no, right? If it's yes, there. If it's no, then you got to keep going a little further. Okay, so add that no there. If the answer is no, you have to kind of see, okay, what can I do here, knowing all the skills that I've learned throughout high school, maybe even elementary, right? Do you have a pair, or do you have side, side, side? Like, is there a way to get more out of this triangle? Use trig to determine the rest. For side, side, side cases, watch this, guys. This is a review, a blast from the past. For side, side, side cases, only check the angle across the longest side. Only check for the angle across the longest side. That's a shortcut. That's going to save you a ton of work, because that's the largest angle, right? If a squared plus b squared minus c squared is positive, you have got yourself an acute angle. If that part is 0, you have a right triangle. If it's negative, you've got an obtuse angle. Before I continue, watch. This is what I mean. Cosine of angle. Sorry. In this case, it has to be c. Cosine of c would be a squared plus b squared minus c squared. And in the denominator, you would have 2 times a times b. Right? Remember that formula? Maybe not. It's been a while. But this is the part you're checking. You just plug in, right? And if this thing is a positive, then you've got an acute triangle. If it's 0, if the top thing you plug this in, you're like, what? I got 0? What's going on here? You've got yourself a right triangle. Okay. If it's negative, it's obtuse. So right would be, there's a 90. Acute is just one of those triangles where like all of them are less than 90. Obtuse, you would have a triangle where one of these are greater than 90, right? So that is what we're talking about here. If you have to use trig, you don't have to use trig very often, to be honest. Okay. Okay. Let's put this to the test. How could you do this based on the short little review, basically, of trigonometry? If I asked you to classify it, name this, how would you do this? We'll go like this. First name, last name. For the first name, you have a choice of acute, right, obtuse. Those are your choices for the first name. For the last name, you've got equilateral, isosceles, or scalene. Those are your choices for the second name, okay? The last name. So let's look at angle, right? Based on the angle, do you notice that? What kind of a triangle is it? Like, which one of these three applies? It's a right triangle. So the first one is right. Because of this, you're narrowing that down to just right. The other ones are gone. Okay? Can't use them. Between equilateral, isosceles, and scalene, which one do you think this would be? No numbers, right? But do you notice the markings? Do you notice that they're all different? So this is a scalene. Did you notice that there's not a single, I mean, there's a 90-degree angle, that's about it, but everything else, no numbers. So these other ones are gone, okay? That's how you do it. Let's go over to this one here. I'm not going to do the 3 options every time, by the way. I'm not going to do that. That's too much work. But this triangle, do you notice that every single angle measures the same? Listen to this part. Every angle measures the same, correct? You know what that tells us? It tells us that all 3 sides are equal as well. There's something cool about knowing all angles. It tells us something about the sides. Okay? All angles are congruent. Therefore, all sides are congruent also. This is just, it's just going to be the case every time. If I tell you that all angles are the same, you can immediately say, oh, well, then I know that all 3 sides are going to be the same also. So what kind of a triangle is it? Let's do the second name first, or the last name. We know this is an equilateral, right? We now know it's equilateral triangle. But what is it in terms of angles? Just look at the shape in this case. It doesn't look obtuse, correct? It doesn't look right. That sounds wrong. But it is acute. It's an acute triangle. Okay? So in that case, I just had to go by what the diagram is providing me with. And it is acute. So I started here, actually, and then I went back to the angles. So there's not one way to do this. Okay? Let's keep going. Remember, you might have to use more than just what's presented at first. You might have to use some of the skills you've learned before. If there's a 90, you're going to start with, like, I wouldn't even hesitate. This is going to be a right something. The problem is it going to be a right scalene? Is it going to be a right isosceles? Right equilateral? What is it going to be? If these 2 sides are the same, listen carefully. If these 2 are the same, I'm going to use a different color here. If these 2 sides are the same, you know that the angles across from them are also the same, guys. That's just a cool property. Okay, so you can say, hey, this side and this side, these are the same sides, so the angles across from them are going to be the same also. It doesn't really make a big difference for us today, but it might down the road. So what kind of triangle is this in terms of side length, you would say? This would be isosceles. Isosceles triangle. Why did you bother with this, Mr. Erickson? I don't get why you did that. That's just like highlighting something that might be handy down the road. For example, could you figure out what the measures are of these 2 angles? Possibly? I would say yes, because let's call this angle A and let's call this angle B. Angle A, this one here, could be found by going 180 minus 90. You take away the 90. And since these two are the same, I can split that in half to get A. So angle A is actually 45 degrees because I go 180 minus 90, which is 90. Divide that by 2, you get 45. It turns out that angle B is also 45, right? So in this case, you can actually find the numerical value of those angles if you had wanted to. Okay. All right, keep going. This one right here. You know what? It's giving me numbers. I'm going to use that to my advantage. Let's call this angle A. I'm going to find that angle because I've got 2. So I'm going to go 180 minus 30 minus 20. That would be 130 degrees. Okay, so that means that this one, I'm going to use a different color just to let everyone know that it wasn't there at first. 130. Now let's name it. Remember, for the first name I have acute, right, or obtuse. Which one am I going to pick there? Obtuse, because this is bigger than 90. So this is obtuse. This one throws students off. In terms of side length, what am I going to pick here? Do you have a single side length here? No. But let's look at it this way. If all 3 angles are different, what do I know about the side lengths? They will all be different as well. That's why if you have all angle measures, you have everything you need to name this thing. Okay? Aren't you excited about that? I think I'm the only one, but that's okay. I will make a note. Note, since all angles are different, I'm just going to say different. All sides are different. Does that make sense, guys? I hope it does. It's just a fact that if angles are all different, the side lengths will all be different. Therefore, what is the only thing that makes sense to put down here? Not all at once, guys. Not all at once. Scalene. Okay, so it's an obtuse scalene triangle. All right, I'm going to pause here for a bit and ask you to do what I'm just doing here. I'm going to say from just pages 8 and 9. Can you do that right now? I want to move on to a different thing, but I'm going to give you a little bit of time to do pages 8 and 9. Let's try it. Page 8. How would you approach this? I see the markings. I see an angle. When you have both, pay close attention to that. You can actually expand what is already given. Do you notice that this side has 25 across from it? We know that because this is the same as that in terms of the length. We know that this angle will be the same as this one. Okay, so this is also 25. You can go ahead and write down that's 25 degrees. And it has to do with the side lengths being the same, and therefore the angles across them have to be the same as well, which now allows you to solve for this one. Right? You go 180 minus 25 minus 25, you're left with 130. Okay, so it's kind of like a chain reaction sometimes. Okay, so we actually now know that in terms of the angles, this one is obtuse. In terms of the Side lengths, we knew that already, that this is isosceles. Okay? So you have an obtuse isosceles there. Okay? Now look at F. F is close. It looks like it's the same. It's an isosceles, right? But these two sides will have angles that are the same across from them, right? So how can you figure these ones out? I would just go 180 minus 80, okay, subtract that one, and then divide it in half. So that would be 100 divided by 2, which is 50. So you know that this is 50 and this is 50. Okay? It's a little different the way I approach this. So, in terms of angles, this one is acute, correct? Because all of them are less than 90. In terms of side length, I know that these two are the same, so this is isosceles. Can I just say something? If this had been 50 right here, this angle 50, so you had 50, 50, 50, what would we know about the side lengths? They're all the same, right? But can we have a triangle that has 50, 50, 50? That adds up to 150, right? That can't be. So let's keep going. What about this one? No numbers whatsoever. You can't find a number if there isn't anything provided. Okay? So we're just going to go by looks. In terms of angles, this one suspiciously looks like an obtuse angle. So I'm just going to say this is obtuse, and all three sides have a marking that is different, that is scalene. Okay. Boom. Oh, there we go, obtuse. Still the same, isn't it? E is just tagging along there. Doesn't really have a job, but anyways. H here, we know this is 90. We know this is 45. So watch what I'm going to do. Immediately, I'm going to go, what am I left with? 45, correct? Oh, wait a minute. If these two are the same, then the sides opposite to them are going to be the same also. Okay? You can draw that conclusion right away. So now, I think we can name this. In terms of angles, this one is right. That one has a giveaway right away at the beginning. And in terms of side lengths, what will I say? Isosceles, right? Because these two angles gave me that information. That's why I say if you have all three angles, you are ready to go. You can name that triangle, okay? Sorry, isosceles. Question for you. If you have all three sides, is that enough to name a triangle, knowing all three sides? The answer is no, that's not good enough. That's not good enough. You'll know how to name it based on side length, but you won't know in terms of the angle. So what would you have to do if it's a side, side, side? What would you have to do? Cosine law. Figure out the angle across the longest side and see whether you get a positive, a 0, or a negative at the top there. And that's how you're going to know. I'm going to leave those for now because I haven't seen those on an exam, to be honest. I'm going to skip now a few pages. I'm going to ask you to go to page 11. And so what I'm going to do is I'm going to do like a spiral lesson this week. So I'm going to come back to triangles sometimes, then I'll move on. And so I'll kind of revisit this topic because I know you're going to miss it, right? So that's why I bring it back. Anyways, what if I ask you to sketch an acute scalene triangle? an acute scalene. How would you do that? How would you convey that message that it is acute and that it is scalene? Okay. This is what I would do. With acute, I would make it look like a roof, like this. And I'm going to say, if this is 50 and that's 50, that's already 100, right? And then that means that this has to be 80, correct? But now I have a problem because this is what? This is an isosceles triangle. Well, why would you do that, Mr. Dirksen? Like, why would you lead us in the wrong? I'm just trying to get you to think, like, don't just put numbers that make sense. So I will make a slight change here. If I make this 60 and this 40, now all angles are different. And it still adds up to 180. And they're still all less than 90. Okay? So this would be good enough. If you really want to make sure your case comes across, you go 1, 2, 3, like all sides are different, right? That's one way of doing it. Just to make sure I would use numbers to make my case that it's less than 90. All of them are less than 90. Obtuse isosceles. When it's an isosceles, I most definitely make it look like a roof, like this. And I make the peak be something greater than 90. Anything greater than 90. Make the peak be that. And then all you need to do is this. That would be good enough. However, if you want to make it more detailed, you go 180 minus 100 is what? 80. So that means that this would have to be 40, and this would also have to be 40. That is fine with me. If you want to fill all of it in with numbers, that's fine. Obtuse scalene. Obtuse scalene. I will make it look like this. Obtuse scalene, I will make this 100. Just use round numbers that work. And after that, you can just do this. Because you're telling me it's obtuse, and you're telling me that all three sides are different. You've made your point. A right isosceles triangle. If it is isosceles, it's symmetrical. Isosceles and equilateral are symmetrical. You can cut them in half. I usually use the roof like this. And I'll put the angle that I want to use to convey my message at the top. So that's a right isosceles. I would say this is not good enough yet. You either have to put more angles down or use markings like this. That is good enough. Acute isosceles. When it's isosceles, I make a roof. I want to make sure that is something less than 90. And I would say check. This one I would say check. If this is 180, how much do I have left to split equally amongst these ones? 100, right? So that would mean that this is 50 and this is 50. So that then you're making sure that the angle you're putting up here actually works, but they're all less than 90 now. Equilateral. That one is the easiest of them all. Okay? Just make one that looks like all sides are the same, and then go boom, boom, boom. What do all angles measure in an equilateral triangle? It's always going to be the case. Does anybody remember? If you split 180 equally in thirds, it's 60, right? So when I give you equilateral ever, you actually know that all angles are 60. There's no exception. Hi there. They're all 60. Okay? That's just how it is. 10 minutes left. Do I torture you with new stuff? No, I won't. This is what I'm going to say here. I'm going to ask you to try pages 12 and 13. This is just naming, classify these ones here. On page 12, write down pages 12 and 13. I'll give you a warning. 13 is for those of you who like a challenge. You need to use trigonometry on 13 and 14, I would actually say. So keep that in mind. It reviews trigonometry, specifically cosine law. Okay? So I'll leave it at that today. Thank you guys for your time. And you survived a math class after the break.